Welcome to the Personalized Immunotherapy Research Lab or PEARL YouTube channel. I'm Stephen Vensko from the Vincent Lab at the University of North Carolina at Chapel Hill, and I'll be your guide today. In this video, we're going to briefly go over the information in the report that LENS generates. So let's start with the basics. The LENS report is a tab-separated file with a header, followed by rows each representing a specific PMHC. That means each row focuses on a combination of an HLA allele and an 8 to 11 mer peptide. Just a heads up though, not every PMHC in the report is guaranteed to be unique. For example, a missense-derived PMHC that is expressed by two highly abundant transcripts will have a row for each transcript ID. If you want more technical info about the report format, then you can find that at uselens.io. Now, when you're actually looking at the LENS report, you'll see columns that define each PMHC. There's the allele column, which shows the HLA allele, and then there's the peptide column, which contains the peptide sequence. Each PMHC comes with a bunch of useful attributes to help determine whether it's worth investigating further. These include binding affinity, presentation, stability, clonality, and relative transcript abundance. For binding affinity, LENS uses McFlurry, and you'll see the relevant columns listed below within the report. Optionally, you can also get affinity data from NetImageCpan, but for that, you'll need to set up your own Docker image. Instructions for doing that are under the Technical tab on the LENS docs at uselens.io. Make sure to check out the official documentation for both McFlurry and NetImageCpan to ensure you're properly interpreting their columns. If you're also interested in binding stability, that can be pulled in using NetImageC-StabPan using your own Docker image. Now let's talk clonality. This is important because clonal variants generally make more attractive targets. You can find clonality info in the CCF column, but note that this data is currently only available for single nucleotide variants, insertions, and deletions. Then there's relative transcript abundance. Different bioinformatics tools measure this in different ways. For instance, Salmon gives you TPM, and StarFusion gives you FFPM. To allow comparisons of relative transcript abundance from various tumor antigen sources, we created a set of columns. You're seeing them on screen now that give a universal metric. They're a bit of a mouthful, but basically, they tell you the number of tumor RNA reads that align to the genomic origin of your peptide either with or without the peptide's coding sequence. All these metrics come together in the priority score columns. These scores give you a quick way to prioritize PMHCs. They range from 0 to 1, where a value closer to 1 means higher priority due to better binding affinity and higher expression. You can learn more about the priority score on the LENS website or in the manuscript linked in the description below. The report also includes antigen source-specific information. This covers the genomic origin of the PMHC, relevant gene and transcript info, as well as virus or retrovirus identifiers. These extra details can help you narrow PMHCs down to the most promising targets. More info on those columns is also at uselens.io. Finally, there are tumor-level metrics in the report. These include the list of tools supporting each HLA allele, whether there's any loss of heterozygosity, and the relative transcript abundance of each HLA allele within the tumor. You'll also find info about the antigen processing and presentation machinery, including mutations and expression levels for genes like B2M-TAP1 and TAP2. And that wraps up our quick tour of the LENS report. Thanks so much for watching. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell so you don't miss future uploads from PEARL. If you've got questions or want us to go deeper into a specific LENS feature, drop a comment below. We'd love to hear from you. Until next time, take care and happy analyzing.